Okay, I'd like to talk about challenges with annotating liver patient data, which is work that Andreas Adler, Patrick Philipp, and I have been doing at KIT together mainly with the University of Heidelberg in a rather huge research project about cognition-guided surgery. And so this is an overview of the project, and there are 15 projects involved, so it's a rather big project, and we are responsible of doing the knowledge to provide them tools for knowledge management, because the whole project it run now for 1 year, and it can run up to 12 years. So you can imagine knowledge management is not a bad idea there, because you have fluctuation and so on. So you have all of these projects, and if you abstract from it, you get this. So you have surgical use cases and you have assistance systems. So within this project, we want to help surgeons to do their work better using an assistance system. And so you can have this more concretely. So we have, for example, the use case of recommending liver therapy, and as a assistance system, we want to have a cognitive assistance system. So within the system, information needs to be perceived also, for example, interoperatively. Then interpretation of this data has to be done with a knowledge base, and then a specific action has to be done. And within this project, you can imagine we are somehow responsible for the knowledge base to provide interpretation algorithm with the relevant information for doing their work. So recommending liver therapy is mainly about, so you have a patient, and this patient might have a liver tumor, and now the surgeons are concerned about what kind of therapy they want to have on this patient. And for that, they have all kinds of guidelines. For example, they have this kind of guideline that would describe if a patient has neuroendocrine metastasis, and those metastases would be asymptomatic, so do not show signs, then you don't do basically anything. You stay, you observe. You let the patient come into the clinic once in a while and check. And if those status of the patient is progressing, then you decide whether you want to resect or ablate, for example, the tumor. And if there is no progression, you continue observing the tumor and the metastasis. So these kind of guidelines you have in this use case. And you've seen that we've talked about a liver factor. So we've talked about a factor of a liver of a patient that is relevant for the surgeon of deciding what kind of therapy is needed for the patient. And in this presentation, I want to speak about how to do this matching between liver factors that are described in literature or in guidelines and actual properties of a patient. And so you can break that down into 3 tasks. First of all, we have describing liver factors. Physicians have to do that. Secondly, physicians have to annotate patients using these liver factors. So you see here, for example, that a patient has a neuroendocrine tumor that is asymptomatic. And then at the end, you have to evaluate guidelines according to these described annotated liver factors. So for example, you would then derive new properties, such as that this patient ID 432 has a therapy that for now we observe it. We further observe this patient. So if we summarize that, we have to bring together different information sources. We have to bring together liver factors from many literature, so there are many medical articles about liver factors, what kind of factors have to be described for a patient. Secondly, you have the patients that are annotated, described with these liver factors, and then you have the therapy guidelines that are, and these patients that, of course, they are not always, they are described electronically. Often you have paper-based patient descriptions. So here's the problem of having this electronically. And also we have therapy guidelines. And again, here's the same thing. We have all of these very nice publications in the medical domain, but they are not annotated. They are not described in a very nice machine-readable way. And all of these different information sources we want to have surgeons to discuss about. The medical domain is very specific. So we have, for example, the following requirements. Security of patient data is the most important one. Secondly, control of metadata and data. The physicians, they want to have control over the metadata and the data. They don't want to have, also in this huge project, there are different projects, and one project is willing to publish data, but they are not willing to have anyone mess around with it. So control of metadata and data is very important. And also we have ease of data import. You can imagine physicians are not technically savvy, so this is also a requirement. Our solution is to, as an overview, we have the interpretation part that we are not too much involved in, because that is mainly other projects' work, so they need to do interpretation algorithms on available data to recommend a specific therapy. This information for this interpretation algorithm is taken from a triple store, and this triple store it has to be within a clinic typically, because data should not be stored outside of the clinic, and the data sources that are used to fill in the triple store are now, we have the liver factor ontology that is describing the liver factors. We have patient data set, we have patients described using these liver factors, and we have a guideline data set describing the guidelines. So this is, and all of those are published as linked data, and not, of course, not linked open data, that's for sure, but we use the linked data principles, so RDF, or HTTP, to have data available in the internet for the interpretation algorithm. So now I've described how we describe the liver factor ontology. So this is done, of course, otherwise I wouldn't be here using Semantic MediaWiki. Here we have the problem is that we have a huge Excel table that was created by the physicians describing more than 500 liver factors. So pre-operative one, intraoperative one, or post-operative ones. And our solution is to use this Excel table and to import it automatically into Semantic MediaWiki. Enhance it with additional information, and then do an RDF export of these liver factors as an ontology that can be looked up by others to, for example, annotate a patient. And the benefit of this approach is that we allow physicians to use an Excel table, and since we use a local SMW version for these surgeons, they have the control over their data. They only publish the ontology after they have created the ontology within their group. Describing those liver factors is mainly an issue of modeling. So here we would identify within this Excel sheet properties. For example, a property has hepatobiliary disease, or has chronic disease, or has chronic cirrhosis. And between these properties, it's quite obvious, is a kind of sub-property of relationship. And also there's other information encoded in the Excel sheet, such as that has chronic hepatitis, can have possible values of that we have a viral hepatitis, we have drugs, through drugs created hepatitis, and so on. Also, there are more complex situations. So here, for example, we do not only have the property has chemotherapy, but we also have additional information like has chemotherapy protocol or duration. And this is a fixed number of, this is basically one dimension that has a fixed number of members. But we also have other situations, such as laboratory data. Here you would have an endless amount of possible dates where such laboratory data is captured. And here you would need, of course, subproperties where you would allow to store the date where this laboratory data was stored and also the value. And then using a laboratory observation sub-object, you would store this information within Semantic MediaWiki. Describing the liver factors this way allows us to give surgeons an overview of these 500 liver factors. For example, showing a graph or showing a tree. Also, we were able to, because surgeons, they would just give us this Excel sheet and it would not be added with any background information. And often, such liver factors may be ambiguous. So we thought, okay, why not enhance it? So what we did, for example, was we enhanced these liver factors with links to background information, such as, it's quite easy, but this is what we did. For example, has chronic cirrhosis would be linked with the Wikipedia article. So this is the first state. We have published a version of the ontology by now, and there are still open challenges. For example, the type of the property, the type of the liver factor, we have to guess often because either they don't want to tell us or they don't know themselves. So the surgeons, they just don't tell us what can be really put for a liver factor. We have to find that out eventually. So for now, many of those liver factors have the type page. Also, we need a kind of liver factor refinement process because you can imagine that these liver factors, they will change over time. So either the type will change, or they will change the name, or they will split up a liver factor into several ones. We already got several versions of this Excel sheet, and we have a hard time of always updating the Semantic MediaWiki with these new versions of the Excel sheets. That's a hard time because round tripping with Semantic MediaWiki, as some of you may know, is very difficult. So the only way that we have is to import the entire Excel sheet again into Semantic MediaWiki. So we don't have a solution for that yet. And also this Excel sheet, I haven't shown you the entire sheet, but it's very dirty. So to be honest, the exceptions are the rules. So it's very difficult to find structure in this liver factor Excel sheet. And without data, it's difficult to validate the modeling, and that is why now I will describe the second data set, or the second part of the information source, which is the patient data set. That is annotating patients using these liver factors. And again, here we use the local Semantic MediaWiki, and we have the problem that the patients are described paper-based. We have around 50 patients that are described, and each of those have several dozens of pages with information described about them. And again, surgeons would like to have an Excel-like data input. So they have given us this Excel sheet, and they don't want to adapt from it. So they want to use this Excel sheet for inserting structured information. And so what we used here, of course, is semantic forms. And we allow using semantic forms in this local Semantic MediaWiki installation to describe a patient using these liver factors from the ontology. And after patients have been described, they are exported using RDF and then can be stored on a file server with access restrictions. And then this way we again make our surgeons happy. So they have ease of data input, and they have a secure way of storing patient data because they can first locally within their group annotate them, discuss patients, and then they are described as RDF, put into basically into the knowledge base in a secure file system. About annotating these liver patients, it was a very easy idea basically, but what we did is we And we pre-processed the Excel sheet. Then we exported this Excel sheet as HTML for filling a template and filling a form. And then surgeons could could annotate patients within Semantic MediaWiki, which still would look very close to the Excel sheet. And here, as an example, we have this part of the Excel sheet describing 4 substitution liver factors. And first of all, we need to identify liver factors within this part of the Excel sheet. So we always use the liver factor that is at the end, at the last column, basically. So here we would have the ringer, for example, and RBC. Don't ask me what kind of liver factors these are. I'm not an expert. But using Excel formulas, of course, we can derive this. And from here, from these variables, we can then create wiki text, such as filling out a template with such information and annotating it. And the same goes for forms. So we can actually create form fields within this Excel sheet. And after we export those templates and forms into Semantic MediaWiki, we get something like that. So this is an example of a filled-in template where we have for a patient filled in information that he basically doesn't have any coagulation factors, which I think should mean that they haven't captured the coagulation factors, because typically this is a more high granular information. And the form looks quite close to the Excel sheet, so surgeons or physicians would fill in those values, and in the background, in the template, those values would be annotated using the liver factors. The same works for more complex liver factors. So I told you about these liver factors that have several values, basically. So here for oncological management, we would have a Has chemotherapy protocol, and the surgeons could also fill in Has chemotherapy duration. So it again looks very similar to the Excel sheet, and physicians can fill in those liver factors that have one dimension that has a fixed number of values. And the same goes for the laboratory values, only that here we actually allow physicians to fill in the date and fill in the value. And from this information that is filled in the form, we can then populate sub-objects with these laboratory values. The status now is that we have 5 student physicians inserting data in their Semantic MediaWiki instantiation. We have so far 20 patients annotated, and we could create first overviews of these patients, which helped physicians a lot to understand the benefit of having structured data. Because before then, and so for now, they just insert information and they don't really know what is done with it. And this overviews of the data afterwards, for example, comparing different patients, this helps them understanding the potential benefit of doing this. But of course, we still have open challenges here. So again, we need a kind of liver factor update process, because these liver factors, they change. And every time they change, it is a lot of effort for the technicians behind it. Because either they just need to change the user interface, that is annoying, but that's okay. But if those changes require different kind of modeling, then there's always the question, what do we do with all these other patients that have been annotated before? Because then we have to update them to the new version. And also, I've already mentioned it, physicians, they just insert data for now, and they don't have a clear understanding of what is the benefit of if we insert higher quality of data of higher quality. So somehow these student physicians, for example, they have spelling errors in their annotations, like 60 minutes, or they use different ways of describing unknown and known, and so on, or they use German dates for the dates. So Of course, there's a lot of, we need to do workshops with them, but these are problems that we basically have with them. And of course, it's not only their fault, but also we need to make sure that the user experience is good enough that they can actually fill in high quality data. But of course, that's always a compromise between flexibility, because they also want to insert new values, and maybe a top-down or a drop-down list where they have a fixed number of possible values. Of course, there's difficult to make an error. Now, for last, we want to describe the guideline dataset. Here, we don't have many. We don't have a solution yet, but what we basically need to do is, again, we would like to use Semantic MediaWiki, because this way we could collaboratively describe guidelines in a Semantic MediaWiki within their group. We don't know yet. There's a bachelor, no, it's a diploma thesis going on, whether it's possible to describe guidelines within Semantic MediaWiki, which would, for example, describe that if someone has a neuroendocrine tumor and that is asymptomatic, then this one should have a therapy of being observed by now. These kind of guidelines. Again, we have challenges here. To describe this in a Semantic MediaWiki, I'm not sure, maybe using templates, that's probably possible, but then again, it's very difficult to collaboratively edit or comment if you encode it in templates. Also, we of course want to execute those guidelines. So we want to derive new properties for a specific patient, for example, using Sparkle Update on a triple store that would encode the rules using Sparkle Update queries, but we don't know yet. And also, we are pretty sure that once we have several guidelines encoded, there will be conflicting guidelines. There will be guidelines that say we have to ablate this tumor, or another one says, no, I think we should just stay and observe this patient further. So, and we need to think about how to present this to a surgeon so that he can either change those guidelines or, I don't know, yeah, maybe it really depends on the situation. As a summary, our lessons learned so far were we have special requirements, of course, in the medical domain. We have sensitive patient data. Surgeons need to have full control over data. It's very difficult for physicians to get around structured data. But we also see that SMW is great for working towards a common vocabulary, so that with this vocabulary we are actually able to map between liver factors, guidelines, and describe liver factors for concrete patients. So I hope I could give you a rough idea of what we are doing within this research project, and I'm now happy to receive any questions or exchange experiences in the coffee break. Thanks.
Thank you. Yes, so are there any questions? Yeah.
Thank you, Benedikt. In the United States, the way that HIPAA requirements are for maintaining confidentiality is for identifying information to be stored in a wholly separate system from the medical information. This seems like a wonderful opportunity for an extension that would provide that kind of technical structure and to coordinate it with the queries, if you will. I'm wondering if this accords with the sort of solutions that you're looking at.
Mm-hmm. Our strategy for now is to really keep the wiki way within Semantic MediaWiki. So to allow physicians to collaborate, to discuss about liver factors, and about then reasoning about these liver factors, we think, will be a separate system. So we will have interpretation algorithms, and those interpretation algorithms will ask one specific information source about, so basically the knowledge base. I have now this use case, I have this problem. I want to recommend a liver therapy. What kind of information can you give me? And then this one would tell him, oh, I have a data set that is stored here, but you need to have this access information. And here you find the rules that are openly available. And here you find liver factors that are used within this data set. And then the interpretation algorithm would then get this information from different sources, reason about it, and maybe put information back into the system. And this process we probably don't want to have within Semantic MediaWiki. We are not sure yet, but I think we really want to have the wiki way and the reasoning about the information separated. Sure.
Hi, you mentioned that you're exporting the RDF data from the wiki, like you're showing right here on the slide. Do you use the RDF format that comes from the Semantic Wiki as it is, or are you doing some kind of processing with it before adding it into rule store?
Yep. For now, the only thing that we do is, since we need to publish this information as linked data, and we need to make sure that all of the URIs that are within this RDF export are resolvable. So one simple thing we need to do is to replace all of the URIs that are, I mean, in the easiest way, it's just called localhost. They need to be mapped to something where it's actually published. That's just an infrastructural thing. Yeah? Apart from that, what we could also imagine is to materialize reasoning information. So that, for example, if you have sub-property information within the RDF, then you could actually materialize part of it and also store it as RDF. Because this RDF file that export is not, it is provided as linked data as a file, and then it is on demand loaded into a triple store for a specific use case. Cool.
Hi.
Yeah.
Just a big question. I mean, you have 50 people's data in there. Do you see that this is potential models for individual hospitals to download and install on their system, or to serve as a point of federation between hospitals?
So general, the linked data principles, they foster a distributed storage of data. So we imagine to allow anyone to provide information to our knowledge base by just publishing linked data and making sure that it's somehow linked from other data sources. But of course, we need to provide search within this huge research project. So we are not speaking too much about connecting different clinics, but we are speaking about connecting different projects. And here, what we do is we provide them with systems where they can actually easily publish linked data. So, for example, just exporting something from Semantic MediaWiki and then putting it onto a file store. But also, we want to promote the linked data principle per se. So we just want to say, if you have a web server and you want to provide information to our knowledge base, just publish it on your web server using these principles and make sure that it is linked somehow from the knowledge base. And from that on, it is part of the knowledge base. Then, of course, we still have the problem of data quality, of reasoning about it, because if just everyone can publish messy data, that might be a problem. But for now, I would be happy with publishing as much medical information as possible and then see how we deal with it afterwards.
Thank you. You stress the need for structured data, but would also unstructured data assist the development of your application? Because findings would identify new parameters to store and to share?
I think the unstructured information is nearly as important as the structured information, because it sets the context for surgeons. So we had several nice examples yesterday where actually the combination of both, so some textual information describing, for example, use case. So this recommending therapy use case, it needs to have some description in the knowledge base that actually we have the problem, that we have patients that have a liver tumor and we don't know what to do with it. And this is mainly free text. But then also connected to it, we have the data that is needed to solve this use case.
Just, I may miss some point, but I mean, my question is, in my understanding, the patient's data is most confidential one, and liver factors or therapy guidelines can be publishable or can be shared. Have you shared or have you shared your data on the internet, or if it's not, where is the difficulty and to do that?
So for now, we are mainly concerned about providing knowledge management solutions within this project. And since there are 15 projects involved, it's already quite a problem. So for now, we're speaking about less confidential information if we publish it for the entire project, which doesn't mean that we publish it for now for the whole world. We have a separate platform that is called Open CAS, where we try to eventually, we have already published some evaluation data, some example data that other groups can use to evaluate the interpretation algorithms. But those are example data only, and those do not contain guidelines yet or liver factors. So we could imagine to eventually make that public to a wider community, but for now we are mostly concerned with bringing people within this huge research project somehow on our side of at least giving some information to the other project.
Okay, so thanks, Benedikt.
Thanks for your feedback.